guys, it's time to learn maths. So before I start, I'll say this. First, today we're learning circle theorem. One of the topics I hated because I don't know why we're studying about circle. But today I'm going to break it down for you with all the theorems that are related, and we'll solve one or two questions and we're done with it. Right, the first theorem. So the first theorem is the alternate segment theorem. Alternate segment theorem. What happens? Mind my circle. If you have a circle, you have a triangle in the circle, and the triangle is pointing down to a tangent. The angle here should be equal to the angle here. We call this the alternate segment theorem. It states in plain English that the angle lies between a tangent and a chord. The chord is equal to the angle subtended by the same chord in the alternate segment. This means segments and this segment is a chord here, and this chord is facing the tangent. So the angle here is equal to the angle here. Alright, so move to the next one. So the next one is angles in the same segment. So it says angles in the same segment are equal. So normally when you have a circle, I have an angle extending like this. The angle here and the angle here are always equal. So angles in the same equal. Right? So we have another simple one. And that one is the chord of a circle. Okay? Chord of a circle. We have a center O. So a line drawn from the center to a chord is always, let me draw the chord first. Chord. So a line drawn from the center to the chord is always perpendicular. That's right angle. So most times when you have a radius here, you have the radius here, it gives you two right angles. It divides this bisects with this line here, so listen to this line here, and your radius and your radius. Okay? Right, so you have the center, angle at the center theorem. So I'm going to take this because this is in two parts. You have the first one, which is I'm going to take the theorem in one here. So sorry. Can I get it? Okay. It says the angle at the center is 2 times the angle at the circumference. This angle at center is equals to 2 times the circumference. That means that now, if you want to know when an angle is at the center of a circumference, imagine we're labeling A, B, and C, and our angle at the center is O. Our center is O. So the angle at the circumference will give me A, C, B. Angle at the center will be A, O, B. So if this side and this side are equal, the only difference you have is this and this. This means that this is working under angle at center theorem. Okay. Now another part of this which we don't know is the angle in a semicircle also follows this angle. Whereby the angle in a semicircle says is always 90 degrees. So it's always 90 degrees. Because the angle at your center is 180. So because it's 180, if you divide it by 2, it gives you 90. Again, we check it at center O, A, B, C. You have A, O, B, which is 180, A, C, B, 180, 190. Sorry, 180 over 2, that is 90 degrees. Alright, so angle at center, angle at circle, angle in a semicircle is an extension of angle at center theorem. Okay, alright, so the next one, we have the cyclic quadrilateral. In a circle, you have a quadrilateral surrounded by a circle. Opposite angle are supplementary. Let me see, x, y, z, w. This means that x plus z is equal to 180, y plus w is equal to 180. Okay? Okay? It says opposite angles are supplementary. So that is angle in a cyclic quadrilateral. And okay, now notice this. If the four ends, the four edges isn't touching the circumference, it is not a cyclic quad. Okay, it's not a cyclic quad. It has to touch this point, this point, this point, this point. So you have something like this that goes like this. It is also a cyclic quadrilateral because it's touching the 4 points. Okay, all right. So I'm gonna do next thing is the tangent of a cycle. So I'm going to do 2. Now the first one says from the center to the tangent is also perpendicular. That means 90. Center O to any tangent is 90. Now tangent is a line that's drawn outside the circumference, it touches the circumference perfectly. So this right here is a tangent. Okay, right. So we have something like this. Then one more, you have this another tangent here and the tangent here. Oh, sorry. The tangent and meet at the same point. O, B, B. And notice it's still 90 and this is 90. So tangent and meet at the same point are always equal. Always equal. So for two tangents, if they meet at the same point, they're equal. Tangent the same equal in length. Okay. Alright, so let's take a quick example. Quick example. So this is from this question by 2004. Okay, so the question is kind of simple. Okay. Sorry. Point K, point L is R. Okay. This is my drawing. Now point Q, point O, point P, and this is 18. If you ask to find Q R S. Okay, so that's the solution. Now the first thing first, you find the center, then find possible theorems that goes along. Now we have a semicircle here. That means there's a possibility we have a 90 here. Noted? You have from the center to the tangent, it's possibility we have a 90 here. Okay? Now this is a radius, and this is a radius. That means you also have an isosceles triangle here. I guess me that is ORQ is an isosceles triangle. And we are asked to find QRS. We know ORS is 90. Okay? And we can get these angles because it is an isosceles triangle. So we already know how to get OQR. So now I'll put it. Now you want to solve it, always write the theorem back in your solution. Okay, so let's go. So first of all, we need to find ORQ now, because ORQ plus QRS is equals to 19. That is tangent of a circle from center is 90. Okay, so now we already have this, so we need to find this. Now ORQ, that is triangle ORQ, is an isosceles triangle. That means that what base angles are equal. Okay, so base angles are equal. So that means to find OKR, we have to use 180, which is some angles in a triangle, minus 80, which is the angle up here, divided by 2 will give us this. So that will be 100 divided by 2, 50. Now when we have 50, all we have to do is to replace this here with 50, we can get our QRS. So we have 50 plus QRS equals to 19. QRS equals to 19 means QRS equals to 14 Y. And that is your answer. Let's take one more example. Trying for something a bit difficult. Let's take this. Let's take this. Okay. Mind my circle and Q. We have to find this one like 2021. So I'm looking for X and Y. Now, definitely we can see this is obviously a cyclic chord. Obviously, it's a cyclic chord. And one thing about cyclic chord is that opposite angles are supplementary. Addition of opposite angles give us 180. And this obviously, since looking for two unknowns, it's obviously obvious we're going to get a simultaneous equation. Obviously, simultaneous equation. So let's start going. So we do x plus y equals to 180. Cyclic chord. Then 2y minus 30 x 180. Okay, there are two ways you can do it. Now, I also have, the way I do my simultaneous equation, I have a very funny shortcut. What I do is I make x solve the formula here, make x solve the formula here, equate both equations, then I get my y. Or I do elimination method. So I think for the sake of time, I'm going to do elimination method. So here we're going to have 2x plus y in this equation on top. 2x plus y equals to 180, equation 1. 2y plus x equals to 180 plus 13. I'm working on the second one. That will be 2y plus x equals to 10. I moved the 30 to the other side. The way you can do that is by adding the 30 to both sides. Alright, so yeah, I have this. For simultaneous, I need to multiply equation 1 by 2. So multiply with 2, sorry. 2. I'm going to have 2x plus y 19 plus 118. So 2 multiply with this, 2 multiply with this, 2 multiply with that. So we have 4x plus 2y 360. Okay, now subtract. Let's make this equation 3. So we have over here 4x minus 2 plus 2y equals 360, and minus x plus 2y equals to 10. Now, one of the things we do in simultaneous equation, when we're elimination method, when we're subtracting, that your sign has to go through everything. So we're going to have minus here, minus here, minus times plus is minus, a minus here. We have definitely this will be off with this, 2y minus 2y is 0. We have 3x is equals to 0, 5, 1. And divide both sides by 3, x is equals to 15. Obviously, so if x is equals to 15, y is equals to, so from my equation 1, we can use equation 2. From equation 2, we do replace x with 15 in equation 2, so we have 2y plus 15 to 10, 2y is equals to 10 plus 50, 2y is equals to 160, I think that's it, and y is equals to 160 over 2, 80 degrees. And that is all. So I think that will be. Thank you for listening. Thank you for listening. That'll be all for now. So join us again at CICST Academy for more maths and codes breakdowns. So thank you for joining. We'd love to have you here. And please try more topics on it. One of the best ways to get better in maths is by practicing. So you need to practice and practice and practice till you get it. So thank you for joining us. God bless. Have a lovely day.